All right, direct variation. Remember, the equation for direct variation is y equals kx. And solving that for the constant of variation k means that's going to be k equals y divided by x, which is what we're going to be looking for on the first part of these two questions. It says if y varies directly with x and y equals 84 when x equals 16, what is the constant of variation k? So we're going to use the equation for k and plug in those two numbers. Okay, so 84 over 16, and then we are going to divide, okay, or at least reduce that fraction. I left my calculator on the other side of the room, so just hold on for a second. The easiest way to reduce that number is to plug it into the calculator as a fraction. Alpha y equals, enter, 84 over 12, and my answer is 7, so k equals 7. Write a direct variation equation to represent the situation. I'm just going to plug the k into this one, so it's going to be y equals 7x. Find the value of y when x equals 8. Well, in that case, we are just going to plug this in, 7 times 8 for x, so y equals 56. That's the solution to that part of the problem. So 7, y equals 7x, y equals 56. Number 7 is very similar. It says if y varies directly with x and y equals 72 when x equals 48, what is the constant of variation? We use the same formula, y divided by x. So this is going to be k equals 72 divided by 48. And let's see if that reduces. 72 divided by 48. It's 3 halves. So 3 halves is my answer there. Now, write a direct variation. So we're going to plug that formula back into this original equation. Y equals 3 halves x. Letter C, you have to read carefully. It says find the value of x when y equals 21, which means that we're going to replace the y with 21 and then solve it for x. I didn't leave you a whole bunch of room here, so I'm going to sort of take all that space. It's 21 equals 3 halves x. So what I would do here is I would say 21 equals 3x divided by 2. I would multiply both sides by 2, which gives me 42 equals 3x. I would divide both sides by 3. Sorry, I have to cram all this in there. And I would get x equals 14. So this is an answer, this is an answer, and this is an answer. I apologize for cramming all that stuff in there, but that's the math that needs to be done for that problem. We've got 2 word problems, both direct variation. First one is, the number of kilograms of water in a human's body varies directly as the person's mass. A person with a mass of 60 kilograms, or 90 kilograms contains 60 kilograms of water. How many kilograms of water are in a person with a mass of 50 kilograms? We're going to do this 2 ways, okay? We're going to make this x, let's make mass x. We're going to make water y. So if we do that, we can say that k equals 60 over 90, which reduces down to 2/3. So y equals 2/3 x. Question is, how many kilograms of water are in a person with a mass of 50? Now, the person's mass is 50, which means it's down here. Okay? So what we're going to do is we are going to, that means it's x. So y equals 2/3 of 50. Okay? And this one you're going to want to put in the calculator because it's going to give you some weird numbers. But 2/3 of 50 is 100/3, which is not a great number. Let's go ahead and change that to a decimal. We'll press math, change to decimal, 33.3 kilograms. Okay, so y equals 33.3 kg. Now, that's sort of the long way that works with these formulas. However, I prefer to do it as a proportion. So if we just say that 90 is to 60, again, this is mass, this is water, is going to be equal to person with a mass of 50, 50 over x. Then we can just cross multiply and solve using that method. So 60 times 50 equals 90 times x. And this is 3,000. This is 90x. And then we divide both sides by 90, and x still equals 33.3. You get the same answer. I prefer this method, so we'll do that on the next one. The electric current I in amperes in a circuit varies directly with voltage. When 12 volts are applied, the current is 4 amperes. What is the current when 18 volts are applied? So here, we can use the same proportion. The one thing we have to be careful of is that we make sure that both of our fractions are the same. So I'm going to say I in amperes is on top. Let's go ahead and say that V for volts is on bottom. So my first situation has 12 volts. Okay, so that's me at the bottom. Current is 4 amperes. That's at the top. What is the current? Okay, so current is amperes. That's X. When 18 volts are applied, that's the bottom. Just got to make sure that everything matches up. Okay? Amps, volts. I'm going to do the same thing we did a second ago. Cross multiply and divide. Okay, so we have 4 times 18 equals 12x. 4 times 18 is 72. So 72 equals 12x. We divide both sides by 12. Divide by 12. And the answer is 6. X equals 6 amps. And that's it. That's what you need to know. Good luck.